We'll now look at the Lisp language Clojure. So it's a functional programming language with support for software transactional memory. Now you may wonder why I suggest that we should use software transactional memory. And the reason why we can do it in Clojure, but I think it's a bad idea for C or C++ and even Java, is that there are much more strict rules about how pointers or references can be used in Clojure and which types can be modified. Okay, so, and this leads to that only very little needs to be logged by the software transactional memory system and checked at transaction commit compared to in C or C++, for instance. Okay, so let's look at what we can do. First, we create a variable or value with this def and set it to 1000, and then we create a class called account with the parameter or attribute balance. And now we create an object here with this start balance as parameter to the constructor. In these slides, I will not explain so much about the syntax, but instead in the source code distributed with the lab, it is an incomplete version of the preflow push, very incomplete, and also the Swish program. There will be comments to not explain what the program does, but how it is expressed in Clojure. So you should read that as a quick tutorial for what is needed for this lab. Okay, but I will talk about some things, obviously, in this video. So we create a class using def record, and give the class name. And then on the next line, we create an object with this class, okay? And give it the parameter as the start value of the attribute balance. Here we create a reference to this object that we just have created. Okay, and this type ref is what it is the modifications to the ref that are logged in the transactional memory system. Okay, and we create this def which points to this reference. Okay. We can see what it points at using dref or at pointer. It's exactly the same. So now let's try, but fail, to update this object, the attribute of this object, by using this syntax to increment it by 5. Okay. When we run this, there is no complaint, but it still prints 1000. And the reason is that we create a new object and do not change the pointer to point to the new object. Okay? So let's try to do that. Then we use the refset. So the beginning here is the same, and what we can try to do now is to use refset to say that pointer should point at the newly created object. And this newly created object will have, if it had succeeded, would have the value 1005. But this doesn't work. And the reason is that we are only allowed to use the refset within a transaction. And there is no transaction here. So let's add a transaction. Okay, we do that with dosync. So this is a sequence of statements that should be executed within the transaction. And we can do that. So we just for doing something, we update this pointer several times, and when we print it now, it becomes 1018. Okay, so this is to give you a very brief introduction to Clojure. In the source code that you will find in the lab, you will find more practical things that can be useful to implement preflow push in Clojure.